We are working on stoichiometry, and now we're going to talk about limiting reactants. So hopefully you've already done the Ed puzzle with Tyler DeWitt, and you realize that sometimes one reactant might run out because we didn't measure it properly. It's not perfect stoichiometry every time, and so we need to figure out which one's going to run out. Okay, so you're going to know this is a limiting reactant problem because you will be given two reactants. There are a lot of different type of problems we've been working on, and you need to start to recognize which problem you have. Okay, so one's going to run out before the other. So how can you determine which one's going to run out? This is important because once one reactant runs out, the reaction is going to completely stop. And the one that runs out is called the limiting reactant, and it's going to determine how much product is produced. That means when we figure out which one's the limiting reactant, we're going to use that to calculate everything else. We'll work on that tomorrow, though. First, for this one, we're just going to figure out which one is limiting. So you definitely need to add these vocabulary words to your notes. The limiting reactant is the one that runs out and determines how much product is made. And we are going to do these problems. We're going to get used to circling the amount in moles that is your limiting reactant because that's going to help us tomorrow with our more complicated problems. Okay, and then the excess reactant is the one that's in excess, and sometimes you see XS, and that will be left over when the reaction stops. So we'll make all our products, but we'll still have one reactant left because the other reactant ran out, and that's why the reaction stopped. So basically, this problem comes down to just one question. When you have those two reactants, if you have a known amount of one, how much of the other one will you need? Okay, so we are definitely given two. Here's our example. And the first thing you need to do for credit is to write your balanced equation. And then you need to ID your two reactants. Okay, so I do have two, but I have to pick one, and it doesn't matter which one you choose. I'm going to pick nitrogen. And then I'm going to determine if I have 3 moles of nitrogen, how many moles of hydrogen will we use? And this basically is a stoichiometry problem, a mole-to-mole stoichiometry problem. So basically, I take my 3 moles and I try to figure out how much hydrogen will react perfectly. I have 3 to 3 moles given, but that doesn't mean they're going to react perfectly. So 3 moles, and I am going from moles to moles. So on my handy dandy mole island, just to show you, you're just going from moles to moles right now, and that's the coefficient from the balanced equation. Okay, so I have my 3 moles. I get rid of my moles of nitrogen, and I go to my moles of hydrogen, and it turns out for 3 moles of nitrogen, I need 9 moles of hydrogen. It's a 3 to 1 ratio. See, I have 1 mole there and 3 moles of hydrogen. So I need 3 times as much hydrogen. So does it make sense that that's 9? Well, I started with 3, and that's 3 times as much, a 1 to 3 ratio. Okay, so now we ask ourselves, I have 9 moles is how much I need of hydrogen. Did I have enough? Well, my original problem said I was only given 3 moles of hydrogen, and I need 9. So I do not have enough hydrogen. So that means that hydrogen is my limiting reactant. It's the one that runs out, and nitrogen is my excess. So what I want you to do is to highlight in moles your limiting reactant, because this is the one that we'll use for our calculations moving forward from this lesson. Okay, now let's see what happens if I picked hydrogen instead of nitrogen, because remember I said it didn't matter which one you picked. So if I pick hydrogen instead of nitrogen, I'm starting with 3 moles of hydrogen. I get rid of hydrogen and go to nitrogen. Here's my coefficients from my balanced equation. Okay. Started with the 3 moles. Here's my coefficients from the balanced equation. And it turns out when I do that mole ratio, here's my question, I need 1 mole of nitrogen. So that's how much I would need for a perfect reaction. So let's go back to our original problem. Did I have enough nitrogen? Well, it said I had 3 moles. I only needed 1, so I have plenty. So this is my excess, and the other guy's my limiting. So you see the outcome is exactly the same, so it doesn't matter which one you pick. When you find out what your limiting reactant is, the other one's the excess. If you find out what your excess is, your other one's your limiting reactant. So now we're going to do 2 problems together. So here's our first problem, and for credit on all these problems, you need to write your balanced equation, ID if you have grams on top and moles below the equation, show all your calculations, and when you're done, highlight or circle the mole quantity that is the limiting reactant. So this says I have 3 grams of nitrogen and 3 grams of hydrogen. Now I just fixed that, I made it 3.0 so I could have more significant digits. And that will be fixed on your worksheet when you get it. Okay, and since they're giving me grams, I need to convert grams to moles to figure this out. So I have 3 moles of nitrogen, and I am going to grams of nitrogen. So here's my single substance conversion. I'm going from nitrogen to nitrogen. It's not stoichiometry, it's just a conversion. Grams to moles, it says to use my molar mass. And this is a problem I'm seeing, and I see every year. Nitrogen is 2 nitrogen atoms together, okay? So I have to add 14.01 plus 14.01 to get my 28.02. So when I take 3.0 and I divide it by my 28.02, I get 0.11 moles of nitrogen. Okay, so now I need to convert my grams of hydrogen into moles because we need to do that mole to mole ratio to figure it out. Okay, so 3 grams of hydrogen gas. Hydrogen gas is 2 hydrogens, so that's 2.02 grams. I need to get rid of grams, put it on the bottom, for every 1 mole. And when I put that in my calculator, I'm going to get, so this is going to give us 1.5 moles of hydrogen, and I'm just going to put it right below my hydrogen, okay? 1.5 moles. Now, here's our question. I have 2 reactants in moles. Which one's going to run out first? So this is our question. If I have this many moles of nitrogen, I'm going to pick this one. How much hydrogen will I actually use up? Okay, so I have 0.11 moles of nitrogen, and I don't want nitrogen anymore. I want moles of hydrogen. And this is my coefficients from my balanced equation. So 3 goes with hydrogen and 1 goes with nitrogen, and that's going to give me 0.33 moles of hydrogen is what I actually need to make a perfect reaction. Do I have 0.33 moles of hydrogen gas? I do. As a matter of fact, I have plenty. I have excess. So this is my excess. And this guy right here is my limiting reactant. Okay? Now, don't be fooled. It's not because this number is lower. It depends on this mole ratio, which can change. Okay? So don't just pick the lowest number. Okay? So you guys have the rest of the worksheet to do. Make sure you write your balanced equation. Make sure you show me your work, and then I want you to highlight the limiting reactant. Okay? So I just want to point out one thing. I started with nitrogen and figured out how much hydrogen. You can pick hydrogen and find out how much nitrogen, and you're going to come up with the same thing, that this would be the limiting reactant, and that would be the excess. So let me know if you need any help.